Hello students, this is Govind sir, and today we are starting our unit 4 that is related to microprocessors, microcontroller and PLC. And in this video we will discuss about the concept, design, interface of microprocessor. And till we have completed 3 units, unit first, second and third, and this is the fourth unit. So let's start with the microprocessor. First question is arised in our mind, that is what is microprocessor? So microprocessor is an electronic circuit that functions as the central processing unit of computer and providing computational control. So it is used as a central processing unit of computer and providing a computational control. And microprocessor is the brain of the computer. The main thing is it is also known as CPU or microprocessor is the brain of a computer. A microprocessor is a component that implements memory. The we can say we have some arrangements of memory in the microprocessor. Clear? So microprocessor is the core of the system. We have some images for microprocessor. All of you or may some of you have know the basic visualization of microprocessor. So this is the chip for microprocessor in the board, and we have different levels of memory in the board also, level 1 and level 2. So this is just a visualization of microprocessors in the board. Clear? Now we have some operations type in microprocessors. All of the operation of microprocessor can be classified into of three types. First one is microprocessor initiated operation. We have some operation which are initiated by microprocessor. Internal operation, which is related to internal architecture of microprocessor. And some we have peripheral initiated operations. That means the devices which are connected to microprocessors, the operations performed by that devices. So we have three type of operations. First one is microprocessor initiated operations. Second one is internal operations. Third one is peripheral initiated operations. So we have microprocessor architecture. The microprocessor can be programmed to perform functions on given data by writing specific instructions into its memory. So it can perform a function that can be given by the instructions. So the microprocessor reads one instruction at a time, matches it with with its instruction set, and performs the data manipulation specified. The result is either stored back into the memory or displayed on the output device. So it can be stored in the memory as well and dis- or displayed out on an output device. So necessary parts or components of microprocessor are CPU, that is central processing unit, IO, that is input output, bus. We have different type of buses in microprocessor: address bus and data bus. And we have CU, that is timing and control unit. We have some special and general purpose registers, and also cache memories L1 and L2. We have some bus interfaces. Okay, so this is all about the basic components of microprocessor, but it is not on the input and output units are not on the same chip. Now, the important thing is block diagram of microprocessor. We have a block diagram of microprocessor very clear to you. We have some registers in the in this block. There are data registers, address registers, and special registers. So for saving the data, we have data registers. For addressing, we have address registers. For special functions, we have some special registers. And we have another, that is execution unit, in which we have ALU and shifter. ALU is arithmetic logical unit that performs some arithmetic operation on the basis of logic. Okay, and we have shifter to shift the sequences and the program codes. and we have program counter that contains the address for the next instruction. So this is the it is also called PC, that is program counter. And in the another block we have control unit. As is its name suggests that it is a control unit. That means it will control the signals, the operations. Okay. And we have another is interrupt interrupt control. We have different type of interrupts also in the processor systems. Now we have debug support, that is on chip debug support, OCDS, and it is bidirectional OCDS, that is OCDS interface. Okay. And the double arrow shows that the data and information exchange between these two units, that is bidirectional. It means it can transfer the data to this unit and receive also. Similarly, it can transfer the data and receive also. And the program counter and the AHB interface is the unidirectional. That means on program counter doesn't receive the data from AHB interface. So what is AHB? AHB is advanced high performance bus. The components which has high bandwidth, and we have to connect them with the microprocessor. Then we have AHB interface, that is advanced high performance bit, in which we have AHB data, that is also bidirectional. We can receive data from the component and we can send the data from the AHB interface. We have AHB address bus, that is related, that is unidirectional. And AHB bus handshake will be bidirectional. Okay. Similarly, AHB acknowledgement, that means the information from the component, and AHB information, that is information from the interface. Okay. So this is all about the basic block diagram of microprocessor, or can say architecture of microprocessor. Clear? In the next lecture we will discuss the other remaining terms like bus interface and timing and control, ALU, etc. Okay. We will meet you in next video.